Hello, guys. Welcome back. Hope you're all safe and well. Welcome to episode 3 of Code and Create with Orbis Connect. We host these every Wednesday, try and get different speakers on, which across a variety of sort of technologies. Today, we've got Juliano, who's senior software engineer at TransferWise. So really excited for this. Juliano helped us out at one of our actual events where people could actually attend a few months ago, or late last year actually. Got gone quick. So yeah, really excited to have Juliano back with us today. He's going to be discussing Shapeless, a sort of basic intro into it, obviously based around Scala. So yeah, really excited for this. We've got a few events like this lined up, so if you're keen to keep an eye out for those, make sure you're signed up to our meetup page, Orbis Connect meetup page. You can find the links via our LinkedIn. We'll send out some links to everyone that's signed up to this as well. So yeah, keep an eye on that for all of our future events, which is going to be pretty busy over the next few months. So yeah, keep an eye out for that. So without further ado, I'm going to get up Juliano. If it will let me, bear with me.
Hello.
Hello, Juliano. How are you?
I'm all right, thank you. How are you doing?
Yeah, not bad, not bad. Where are you currently based at the moment?
I live in Bethnal Green, close to the Victoria Park.
Ah, okay, not too far from Gray then. Who's mentioned
Yeah.
he's in Hackney.
Yeah.
Yeah, let us know where you're tuning in from, guys. If you're on Crowdcast, let us know in the chat box, which is that side, I think, to me, where you're tuning in from. Yeah, that's it. And if you're on LinkedIn, let us know in the comments. We'll be keeping an eye on that as well. How's how you getting on anyway, Juliano? Working from home, how's it
Oh, yeah.
treating you?
Safe and sound, using the whole situation as excuse so I can keep growing my beard because I
Yeah,
have the perfect one to say I cannot go to the barber shop anymore, and then I can
well,
see
yeah,
how far it goes from
it's
here.
going well. How's things work wise anyway? Transfer wise, how are they dealing with everything? I guess they almost had the infrastructure there set up anyway, did they, for
Yeah.
situations like this?
Yeah, TransferWise is a company. The whole business is pretty much online, was already online, right? And because we have offices all over the place,
Yeah,
all the infrastructure was already in place. I suppose the biggest challenge was regarding to the teams that are the non-technical teams, let's say operational
yeah,
teams, for instance. They are the ones that actually had to change their procedures, or let's say HR or onboarding team, onboarding people entirely remotely. I suppose that's a big change.
yeah. Yeah,
So
we're seeing that with a lot of clients we're working with now. So, yeah, look, I'll let you crack on now. Any questions anyone has for Juliano, be it on Crowdcast or LinkedIn, get them in, and if there's any, we'll get round to them at the end. So I'll let you crack on, Juliano. I'll take myself off screen.
thank you very much. So first of all, thanks all for being here to dedicate some time to hear me talking about something that's a bit specific from the Scala world, let's say. Uh, and thanks for the invite. So let's go to it first. Where is it? Oh, I think I should share first my screen. No, it's not this one. Okay, this share. All right. Oh, I like this Inception thing. Okay. So, is everyone seeing my slides?
Yeah, all good, Juliano.
Okay. All right. Thank you. So, uh, let me. As the title already says, I'll be talking a little bit about Shapeless. That's an interesting tool that's very present in the Scala world, directly or indirectly. So, I forgot to translate this one. This one is this means who am I? And I'm Juliano, and that sentence already gives up that I'm Brazilian, right? I live here in London. Saying it's been almost 5 years now, so I'm pretty much a Londoner nowadays. I am a software engineer. I am the searcher of perfect modularization, and I'm the lover of functional languages. A big fan of Game of Thrones. I found it so cool to introduce yourself with this sort of titles. I have experience with some of the cool functional languages, and I have a lot more experience with the vintage ones. Besides, I am, oh yeah, that's my Twitter. Follow me on Twitter. And that's my website where commonly I'll be blogging about things I'm studying, mostly about Scala and Rust at the moment. And last but not least, I am an open source contributor. At the moment, I am one of the maintainers of Quill. Um, if you don't know Quill, have a look like this. This quick GIF just shows you what it does, but it pretty much allows you to manipulate your database the same way you deal with your Scala collections. So just writing regular Scala code, and then you have queries being generated in compile time. Super cool. Have a look. So, well, how did it start? Well, first, we are all locked at home, right? And that's the sort of thing that drives us nuts because our whole life changed a lot due to Corona. So when you are locked at home, what do? You start coming up with new things to do, right? And then what did I do? In January, yeah, I think it was in January, I was traveling with a friend, and he's Brazilian as well, and we are discussing about um, some of the data we have available. No, actually, the discussion was about how difficult it is to see data from the government, how to understand how the government is actually spending the money the government receives from the population. So, long story short, I started exploring some of the APIs that are actually open source, that not open source, but they are public data, right? So we have this guy here, Portal de Transparência. That means something like transparency gateway, something like that in Portuguese. Um, and I started exploring that because I was my friend is not an engineer. He works in finance, so he knows how to build how's it called? He know different ways to manipulate data, right? So the idea was, okay, let's see what we can do with this data and maybe build something useful and expose that to the population. So I started this project. That's pretty much a way to explore this API. It was the first time looking at that, right? So it changed actually, but no, it's that's the URL. You can go and have a look if you want. And then because I started doing so, I wanted to do something cool. So I started studying using this client as a lab for me to learn Zio. Zio is the coolest, nicest, and newest Scala tool that came up from John DeGoy's team. What's a very interesting one. So if you haven't heard about Zio, and you find Scala very complex, I would suggest you to have a look because Zio makes the thing very performatic and relatively easy to learn. Okay, so I started building my client with Zio, right? And then let me tell you what I had at that moment. So that was the project. So we have this idea of a service with Zio, and then I had my HTTP client. And this one here is Zio stuff. This has service is just to say an HTTP client can be used as a dependency, right? I won't get into the details of Zio. And then I had my service here. That's this guy, and then that's the URL, the root URL. And that API, what I need from that is just some information. So I'm just sending GET requests, right? So giving this URI, that's the resource here, some parameters that would be used as query strings, and then I would have an implicit decoder. Okay, uh, assuming that there are people out there watching it that don't know Scala, decoder, this implicit decoder is just a definition to say how I decode something, right? And this T is a generic one, because at this point I was just defining the specification of how a GET request works, all right? So it will take a decoder of whatever, it will generate a task of that whatever. I'll show you in a second the concrete implementation of that as well. So that's just that. That's just a GET request, the definition of one. And this is mostly Zio stuff, okay? So then again, if you don't know Zio, have a look. But the interesting thing is that Zio reflects not just the result of a computation and the possible failure of the computation, it has the environment as well. That's how it work out dependencies among functions, right? Between functions. So what this one do here is just access the environment for an HTTP client, and then that one will give me a function that actually return a list here. And this one does something similar, but this one I made its helper just for IDs. So I have the resource here and then the ID at the end, right? That's not that important. So let's go to the next one. This is an implementation that's quite trivial for people that are familiar with Scala, especially HTTP4S. But the important points are, I need a client. That's the one that will actually perform the request, right? It's an implementation of the service I defined. And I'm using the HTTP4S client DSL here just to help me out. Task is, let's say, something similar to Cats.io, something similar to some extent to Scala or Java Future, okay? It's just a computation that will eventually give you a result. So just implementing that, that's the same signature as before, but I suppose the implementation is quite trivial here, right? So I'll generate an URI from the path, that's the URL plus resource, and then I'll use this with query parameters that pretty much takes the map, right, and transforms it into the query string. This is more Zio stuff. No worry about it. It just says that when you perform that computation, it can fail or it can succeed, and it just delivers back the result, the exception or the result of my GET request. All right, pretty much standard. Just a quick introduction about how Zio knows how to use its dependencies is that you define the concept of a layer, right? So if I say that I define here this function HTTP4S, that's a UR layer that has a client task and producer has a service here. So I can just build my dependency. You know, when you work with, I don't know, Spring, and it solves the dependency for you with some magical annotations, here you just define yourself how those layers are solved, okay? Not that important as well. I know I'm a bit far from Shapeless, but I'm getting there, all right? This is called the module pattern. So if you go to the documentation, you can easily learn about it. It's very interesting. Strongly recommended. And yeah, at this point, I was like, that's cool. Now I have my first simple project with Zio. If you never tried, give it a go. It's awesome. So far, okay. What's the problem? Why I've been talking about Zio for the last 10 minutes, and the talk is actually named Shapeless. Well, that was just a generic HTTP client, an HTTP client, right? Very, very generic. So let's make it a bit more concrete. Let's consume a resource with that. So as you can see here, I have the client again. And I didn't translate that. Those names are, these words like órgão, they are in Portuguese, obviously, because it's in a Portuguese, a Brazilian API, right? And the most likely is if someone will help me out with that later on, they will be Brazilians as well. So I decided to leave it in Portuguese. But I hope you guys can see that one because there are a few things in front of mine here. But this is a client. This is the name of an organ, and it takes this organ request. I pretty much we have, let's say, resources A, B, and C. I just call them the requests: A request, B request, C request, right? And that's the case class here that reflects the return of that request. So as you can see here, it's pretty simple because of all the heavy lifting was made here as well. I just have to say, okay, I want to call a get. This is just more lazy stuff in the sense of I'm saying I have that this method, this function here will return a real that says, okay, I have in my environment an HTTP client, and that produce a list, right? So I will just call the get here, saying, okay, that's just using the type class here, say Argon CF. That's what I want. And this one is the request, and everything else is already done. It will produce the list of results that I wanted. The interesting thing is I haven't managed to solve the parameters yet, right? So it's time to do so. Having this request, as I mentioned, right? These guys are the results for the requests. Those two can use the same request. What could I do here? Well, that's pretty trivial, isn't it? I could go with a to map and then just implement what I need. But I'm a Scala developer, and going with a Java-ish solution is almost offensive. I'm not doing that. Especially because when I have a look at the amount of resources I have and the amount of different requests I would have to write down for every single one of them, that's not a smart solution. I don't want to write to map for every single one of them. So that's the implementation of that one I mentioned before, the organ request. Just ignoring the fact that it's Portuguese, it's pretty simple. Remember that this map will be a query string. So I decide to just use the name here of the field to be the key of my map, and the value, obviously, it's the value of the map. So the interesting thing is everything I need to put that map together is already here. I already have that information. Why should I keep writing it down by myself? That's a really dumb thing to do. So yeah, Shapeless was the solution I could find. For the ones that don't know about it, okay, actually, for the ones that are familiar with Scala, even if you don't know that much about Shapeless, Shapeless is present in many of the famous libraries use. For instance, like most of the libraries that parse JSON, for instance, use Shapeless, like Circe. It's a powerful library that is behind many of the libraries we use on our everyday job. So I started before that. I started when I started looking for a smarter solution. Someone said on Stack Overflow, "Oh yeah, you can just use Shapeless to do so," something like that, and the code was there. I obviously just copied and pasted it and gave it a try, and then it worked to some extent, and I had absolutely no idea why that would work, and I don't like that. So, giving our free time during the pandemic situation, what did I do? I decided to go to the website. There's a free book about Shapeless, and I just read the book, the whole book, in about a week. And now I decided that that's why I'm sharing some of the knowledge with you. This is the knowledge I acquired learning that book. It's a very interesting one, by the way. So, okay, let me show you some code here. You know, oops. Okay, I hope, let's see. Okay, so here I'm in that project, right? So first I'll import the domain so I can use that org request I mentioned. So I have here same I mentioned before, right? An organ request, it has two options, right? An option that's code would be in English a code. This one is a description and a number, whatever the number is, right? So you can see it here. The first thing, the most basic thing I could find with Shapeless first was, okay, I have this guy, and what Shapeless, okay, about Shapeless first. What Shapeless do is it allows us to make a generic representation of our case classes, right? And how does it do it? It uses a construction called heterogeneous list, or more commonly called as age list. So an age list could represent anything in that sense. Let's say, for instance, I have here my organ request that has a sum, another sum, and a 10, right? This could be a list in the sense of sum, sum, desk. It's actually a string, right? But whatever. And then an int, 10. So what Shapeless does is providing us with constructions that will allow us to transform our classes in something generic like that. So the first one I'll show you is the generic representation, the most trivial one. It's this guy, this class called generic, right? So I'm declaring a generic of my case class organ request. And if you have a look here, it will generate this type that has this type wrap. What's an option string, then another option string, and an int. And this last guy, shapeless hnew, it's like, you know, new from Scala, that's an empty list. In that case, hnew is there to say, okay, that's the end of the list. It's the last element. The same way you, yeah, it's pretty much an empty one, just to indicate that it got to an end. So our gen here, oops, has the representation that I mentioned before. And interesting enough, like I said, it works for absolutely anything. So if I have a case class park here with size, I don't know, int, and being open is important nowadays, boolean and a name. I can just say generic of park, and then Shapeless will create that generic representation for me, right? So having that, I can apply this representation, this generic representation, to something else. Remember, I have not something to something that fits that shape. So I have my request here, right? So I can say that now that I have a generic representation, I want to transform that request. And then now I have a generic representation of my organ request, where it's the sum, desk, and 10. That's very similar to that list I wrote before, right? So that's basically the most basic structure on Shapeless. And almost everything that Shapeless gives us, all the tooling, is built around that. Okay, so considering that I have that, and that I have this representation for this guy, let's be honest here, that's not that useful, right? I mean, it's not that difficult to find these values all by myself. What I need is actually the names of those fields. Those are the information that I will actually need to build my map. So what I can do here is using a different type class. I had generic, right? So I will use now labeled generic. Oops. And with labeled generic, I have another representation that's a bit bigger. But as you can see, I will try to highlight for you here. Type wrap option, option string, yeah. So can you see we have this key tag here, and then we have symbols, and more important, we have this shapeless tagged. And at this point, I have the name of the first field here, the name, which is an option of string, as we know, and then we have the other ones as well. The other one is here, and the last one is here. So I have the names of every single one of them. And then I can apply that one as well. Oops. To request. Oh yeah, we cannot see that in that way, but as you can see here, the information we need, it's already there during compile time. I define that, and now I have all the information I need. From this point on, having that information, I could carry on digging into Shapeless to extract that information all by myself, but that's not a smart way to do so. Shapeless provides us with many type of classes that already abstract some of the things I'd like to do here. So remember that what I'm looking for is to make this representation, turn this request into a map. So now we will use another one of Shapeless classes here. Because then again, that's why I showed you the label generic, because everything is built on top of that, right? And I think without knowing about generic and labeled generic, Shapeless looks extremely magical. So it's complex, but it's vital to understand they are there. Because the next one I'll show you without it, that actually makes everything quite magical, but not as much if we have that. So the knowledge about labeled generic. So let's have shapeless dot ops dot product to map. Yes. So I imported this to map, which will give us something closer from what we were looking for. So organ or request. When I do that, I'll have a new type class here where it has less noise than the label generic one, right? Like this one has a lot more information that we don't need, but to map gives us here a type key. Obviously, that's a symbol with some tagged things, but here we can clearly see that we have the strings, the names of the fields, and then I can use this guy to the request as well. To the request once it's defined. And when I apply that, I have a map with, as you can see here, string pagina with string, no, more important, here, map. We have the map with the symbols pointing at the values. That's pretty much what we're looking for, right? And something that can make it even nicer is that instead of using this one, I will use the syntax that Shapeless provides me. So I can just call to map. And then, oops, to the next part. Part, shapeless, syntax. Okay, imported the wrong one. Request.toMap, and now I have this one as well. And even better, I can make it a bit more specific, applying some restrictions. So I know that's a symbol, and my request can have anything, right? I mean, I have options of strings and booleans and whatnot. So I can call just a request to map with any here. And at this point, I have the map that I needed. So if I go back to my slides, I can show you what was the final. Instead of course, instead of carry on with on my terminal, I can show you the code that was my final solution for that problem. So then again, for non-Scala speakers, I defined an implicit class. Implicit class is a class that I define as long as I define some restrictions, and I bring it to the context. Other classes that fit to those restrictions can use it. Maybe an easier explanation is if you are familiar with C#.NET, you have extension methods, right? Let's say that implicits in Scala are similar to the extension methods in the C# world, all right? So it's a way to extend a class that doesn't belong to me. I don't have access to that code. I cannot change it, but I have a way to extend it. So the important points here are I'm adding this method that I call just parameters, and I take this implicit here. I'll talk about it in a second. But the point being, this A here, this vol A here is the request, right? It's the case class. So I call that toMap and the symbol any, as I just showed you. And then from that point on, it's quite simple because I can have options and maybe possibly no values, right? We never know. So what I did was simple. I just filtered them out. So if it's an option, it has to have a value. If it's anything else cannot be null, so I can just map that from strings the way I need it, right? Two advanced, maybe the most complex topics here. What I call the restriction, it's here, right? I have the type restriction where I say that the class that that can borrow this method has to be a subclass of product. If you reading that book, not just that book, but a product is something very present in categories theory and functional programming. But to make it very simple, let's say that every case class in Scala is a product. And that's literally true. If you have a look at the code of case class, you see that they extend the Scala product. So that's the way that Shapeless can define some restrictions here. You have co-products as well, but that working out with products is probably the simplest way. The second one is this implicit toMap. This toMap here is the type class I use to call the toMap here, right? In the code in my console, in my shell. So why I'm using this toMap aux here? That's the most interesting part of reading Shapeless Book, because you learn a lot about the type system, the Scala type system, and a lot about concepts that if you're familiar with, or better than that, if you're not familiar with that, but you've heard about it, concepts from categories theory, let's say dependent types, you learn a lot about it because Shapeless is a concrete example of many of those concepts. So this aux pattern here is very present in Shapeless. You don't have to worry that much about it. If you would use Shapeless, okay, long story short, it retains information for Shapeless, so it's easier to manipulate the code later on if you have that information. So Shapeless uses that a lot in like internally. All right, so what changed, right? That's the final solution. If you go to the GitHub, it's slightly different now because I have to deal with dates and dates with like arbitrary formats, but that's the general solution I managed to put together. So what changes here? That's the client, right? The service, the definition of my HTTP client, and nothing changed here. I don't need my Java-ish solution with implementing that to map, so I can just remove it. The change goes in the client, actually, right? Because those are the guys that don't have a clear definition yet of what happens. So it became very simple. I just have to import that implicit class, that they call it HTTP request ops, and this is solved via implicit resolution. This gray code here, it's not actually there. Not literally, you don't have to write that down. It's not necessary, right? If you're not familiar with Scala, what happens is that bringing that to the context, you can just call request.parameters. Then again, it's similar to extension methods in C#. So from now on, I don't have to worry about that anymore. So for every new client I create, as long as this class is in the, I bring this class to the scope, I just have to import it. I can call request.parameters, and it will work for every single class that's a case class, that's a product, actually, right? So actually, I think I can show that one as well. No. Oh yeah, so no. I think I moved that. Oops. So import. So now I have request.parameters. Just create the map the way I need. That's a map of strings. And then again, that's applicable to any case class, right? So I had a case class, what was that? Case class park. So if I create here a park, size 100, it's open, audience park, dot request, oops, sorry, not dot request, dot parameters. It's already there. So from now on, it's absolutely trivial to generate a map from a case class. And the nicest thing is I will never have to write this code again. From now on, I can always use that small function to solve this problem to me. So a bit more about Shapeless, you can start having a look at the blog post I wrote that was the one that inspired this talk, right? Shapeless, a real world use case. And that's the book I mentioned, The Type Astronaut's Guide to Shapeless. What then again, it can be relatively difficult. It can be relatively difficult to read it. For instance, if you don't know Scala, it's impossible. But even for Scala developers, it can be relatively complex. However, I still recommend that because you learn a lot about type systems, and then again about concepts like the dependent types and phantom types that are being applied in a concrete example. So the conclusion is Shapeless can help you to learn type system, type classes. And after learning how Shapeless works, I would say that libraries like Circe, they make a lot more sense because not just the type system makes a lot more sense, but the implicit resolution makes more sense. What Scala developers know that can be one of the headaches of working in that ecosystem. But I think it was worth it because then again, all the time that I could be writing those two maps, I invested in learning how to create that write that in a generic way, and I'll never have to do that again. So I think it was a very well, my time was very well used in that moment. So that's it. Do we have any questions?
Great, thanks for that, Juliano. Yeah, really, really interesting, even from sort of non-programmer's point of view, like myself. Yeah, so I mean, I guess I was actually going to ask what the book was that you read, but we'll make sure that a link gets sent round to that to
Mhm.
the book you mentioned. Was it the Type Astronauts? Was it you mentioned?
Yeah, I'll share the links later. If you go to my blog, you can find it. I'll share the presentation as well, and then you can send it to everyone attending.
Yeah,
Uh, but
that'd be brilliant. Yeah, we'll get that sent around to everyone who's viewing on Crowdcast or our Meetup page or LinkedIn. Um,
besides,
so
Shapeless is relative. It's not the sort of thing that everyone is. You don't use it on your everyday job most of the time, right? That was this example I managed to find. It was a very specific one because you don't use it most of the time. Shapeless is complex. So what happens is like if you start googling for like a shapeless book, it's really easy to find because you don't have many books out there.
yeah, I imagine. Yeah, I was going to ask that actually. So you say it's complex. So for anyone sort of new to Scala or just getting into Scala, as a language, is Shapeless something that you'd recommend in terms of
No,
getting to know? No, not at all.
absolutely not. No, 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 no. If you are starting, I would say if you are starting in Scala but you come from Haskell, let's say, or if you're someone that's a student of categories theory, I suppose it would be very that would be useful and easier to understand. If you are a programmer that wants to learn Scala, don't go for it. Like absolutely not. It's not. It doesn't have a practical use most of the time. Um, the two I mentioned before, Zio, for instance, because when you are learning, you want to build something that's useful, right? Something tangible, and could be, let's say, a API client or a HTTP server or some like even a common CRUD, something we are building on our everyday jobs, right? Like exposing APIs. I would recommend to go for Zio first. In that case, it's an ecosystem that's growing and it's a lot more useful in that sense. Shapeless is a lot more specific. It's the sort of tool that just library designers use.
Sorry,
So
that was my front door that just just
that's
started
okay.
banging. Then the wonders of live. Sorry, one sec. Yeah, lovely. Thanks, mate. Yeah, cheers.
But yeah,
Oh,
don't the name of the
postmen are
link.
always reliable in these times.
Mm.
Sorry, Juliano. Go on. Go ahead.
No, no problem. It's just about Shapeless is something a bit more advanced and doesn't is not that practical. Let's say you don't use that in your everyday job. So if you want to learn Scala, don't even think about that. If you're thinking about how to make um, your constructions a bit more generic, I want to learn how Circe derives random things, how it parses JSON and read JSON back would be an interesting exercise, but it's still quite complex.
Yeah. Okay. Cool. That sort of covers my next question. I was going to ask you about Zio actually. Obviously, the first part of your presentation mentioned it. It sounds like that is quite useful. Zio.
Yeah, I think Zio, it has, there's one thing about the functional programming world that it's my feeling that many programmers assume that everyone knows about functional concepts like monads and whatnot, right? The scary words. And I don't think that's the case. The problem with that is new tools tend to be built on top of that, assuming everyone understands. So how could we actually have a bigger adoption of new tools if to learn how to use, I don't know, to learn how to dance, you need a PhD in gravity first. It's way too much, right? I think
Very good way of
Zio,
putting it. Yeah.
and I think Zio is the guys that designed Zio. I think they thought a lot about it in that sense. It's designed to be easier to use. You don't have like that amount of magic. You have to understand a bit of type system, obviously, but uh, you don't have to keep like adding like restrictions and many things that make not just make the code harder, but it looks harder. I think
Yeah.
many times the Scala looks harder than it actually is. And that whole part about thinking carefully about a zero layer, for instance, where you just have those restrictions, where you clearly have, okay, you have an environment here, you have possibly an exception, and you have this result. Everything built around that, the way that zero is designed makes, from my perspective, it brings to the Scala world um, a way to make it usable for everyone. It's a lot easier to make sense out of it, and they are working out concepts that are very present in other environments. Let's say dependency injection, right? They are calling that dependency injection, and it is. It's just a different mechanism to solve to sort this out. What's brilliant, and why should we try to convince people that they have to compose something with monad whatever when they could say no, no, oh yeah, we have the idea of dependency injection, you solve it doing that. People already know what that is, so they just have to learn a slightly different way. So I think that that's being a maintainer of a library as well. I would say that more important than just solving that problem, you have to think of how you make it that easy for everyone. It's not about just your problem when you want to make it public and you want to expand your adoption. It's about
Yeah.
thinking of how do I make it as easy as possible. And even though I would say the CATS stack has that in mind, I would say that this Zio stack is more like how do I make it? It's not just for Scala developers, but for more people, for developers that don't know Scala yet. So it's a good way to start.
Cool. We've got a question in here. Juliano from Christie. I guess you've spoke about this briefly during the presentation
Mhm.
in terms of how it can help Shapeless, but how does it impact? What impact does it have on compile time?
So that's the famous problem with Shapeless, because to do that, if you keep not with Shapeless, this problem is famous for Circe. So for the ones that know Circe, I think I mentioned before, Circe is a library used to parse JSON, right? Circe has a mechanism called auto derivation, and if you use that and you keep adding more classes, so Circe will have to kind of read and figure by itself how to derive your classes, how you transform your class in JSON and vice versa. And the more classes you add, the slower it gets because it takes more time reading everything. Shapeless is the same problem because Circe is written on top of Shapeless. So if you keep adding more and more and more and more classes and make the whole thing to do it by itself, it's a problem. The solution I wrote is not the case, right? It's because I'm giving the class. Okay, the problem with Circe is you are dealing with many unknowns. So if you tell it to figure it by itself, it will spend time trying to figure it by itself.
Yeah.
The solution I wrote is it's an extremely simple solution in comparison. So I give it the class I want them to transform it to me. So it doesn't matter how many classes I'm adding because it's not trying to figure by itself how to parse the class. So from such a small thing, it wouldn't be a problem. If you're working with Circe, anyone with experience would tell you that that will become a problem. But just because you're exaggerating on the auto derivation, if you are transforming things by yourself, it won't bring any impact.
Okay, cool. So I guess to summarize then, Juliano, Shapeless in general, I mean, what would you say? I know I appreciate you've touched on a few pros and cons already, but what would you say are the main sort of pros and cons of Shapeless and using it in your sort of um, day-to-day life?
I would give pros about learning Shapeless. I think the most useful thing for me was about studying that, then using that, because then again, don't use that on your everyday life. Like, unless you find a very, very specific case, don't do that. The code you produce with Shapeless tend to be a lot more complex than the rest of your code in your database. If you go to that project, it's on my GitHub, you see that the implicit class I wrote using Shapeless in comparison to everything else, it's like 20 times more complex, right? You look just at class, things don't make exact that much sense. They seem like it's difficult to make a reason out of that. You shouldn't use that on your everyday job. Um, but as an exercise to become a better programmer, I strongly recommend that. In that book, you have some examples of, for instance, how to parse CSVs. And there's a very interesting one where, when you write migrations for your database, it's like writing migrations to one class. So because a migration is like, okay, I have table 1 with column 1, and then same table with column 2, same table with column 3, and then I remove column 1. And in that book, it teaches you how to do that with a class while you're executing your code, compiling your code. It's wonderful. It's a very interesting exercise, very difficult, not useful at all. Not useful in practical terms at all. But knowing that, the amount of knowledge acquired reading that book, I think it was what worth it. Like, I, I get I won't use Shapeless most of the time, like probably not even 1% of my time, but the time invested learning that, it pays off. It's what you learn from that is the return of investment of Shapeless.
Yeah.
Yeah.
Cool.
Many complex things they make a lot more sense after that, like Circe. Everything makes a lot more sense.
Yeah. Cool. I think that summarizes it quite well. Really appreciate your time, Juliano. Like you mentioned earlier, we're going to have all this presentation, links to Juliano's blogs, GitHub. We can get that all sent out to everyone. So, yeah, special thanks to Juliano. Thanks to my postman as well for making an appearance. And yeah, join us next week, guys. We've got GCP specialist coming on doing a presentation, which should be fun as always. So yeah, Juliano, thanks again, and we'll catch up soon, I'm sure.
Oh, will do. It was a pleasure to be here. Thank you.
Thanks again. Cheers, guys. See you all later.
See you, bro.
Stay safe.